it's time for our next speaker. Um, so while he's setting up, I'll just introduce him. He's Argha Manna. I hope I pronounced his name correctly. Um, so Argha started his career doing a PhD in the Bose Institute. Okay, he was a doctoral student at the Bose Institute working on tumor cell migration in 3D environment. And well, currently he's not going to talk about that because that is quite boring. But he is a comic artist. Okay, so he makes a lot of comics and he's become very popular over the last few years because of his comics. But even his research career was quite stellar. He's published. He's a first author. Um, he's a first author in a publication called Immunity, which has a 21 impact factor, and he has few other papers as well in a lot of great journals. But he didn't end up finishing his PhD because he had some personal reasons, and there was not a lot of support from the Bose Institute. So I blame Bose Institute mostly for that. But luckily enough, he joined as a journalist at the very famous Anand Bazar Patrika, and he was a science journalist for 5 years after he quit his PhD. And then he did have some artistic rumblings inside of him, so he started making comics, he started painting, and his comics are really a sight to behold. You guys should check out his website. And he makes comics at the intersection of history of science, popularizing science, mental health issues, and things like that. And so this he's just been doing on his own, but now he's getting a lot of recognition for his work. He's been conducting workshops at the Calcutta Center for Creativity, National Center for Biological Sciences, and also TAFR, right? So, so he really thinks that using words are not the only way we should communicate science, and the visuals have a deeper way of changing the way we think about how we can communicate certain scientific concepts, and not just communicating but even defining and understanding them. So once they get the setup ready, you guys will start. Okay, let's give him a big hand because he traveled for 12 hours.
Okay, thanks. So, my name is Argha and I am a comics artist. So, the title of this talk is, thanks, Challenging Image Tech Dichotomy in Science Through Comics. Actually, I've changed the title, it's put in the poster a little bit. So, through the history, when human actually started doing science and also doing art, this is a existing and nagging question or tug of war between science and art. So, image tech dichotomy still exists, though in 21st century we are in a era where image is trying to dominate and the scientists are collaborating with many artists. Still, so the history, it's a question and it exists, and science can do its thing separately and single-handedly. That means science can stand alone, at least scientific theory can stand alone, but image cannot. If you want to add image in the science, it will be pedagogical, or its role will be like decorative, not not performative. So this is the debate actually. Most of the historian of science, they think it's decorative, and very few people think no, it's performative. And a new blended form of art, image, and science is a new form of knowledge. It could be at least. So I am in the second part. I want to advocate this concept. The image can be performative and not in terms of communication. Image can create new knowledge. So, well, the answer how image can create a knowledge or why the dichotomy exists and how it got started, we need to focus on different ages of human history, like ancient period, then Middle Age, then pre-Renaissance period, then the Italian or European Renaissance happened in Italy, then the Age of Enlightenment. Age of Enlightenment is basically the 17th century when the Royal Society of London built up, and we can say the journey of modern science actually started, and the modern science era where we exist actually. So let's start with the birth of image text dichotomy, how it got started, why image and text has been considered as the binary opposites. It cannot be intermingled. There cannot be a shake hand between these paradigms. So this is the woodcutter of Pliny the Elder. Actually, nobody knows how he looked like, but well, this is Pliny the Elder from Rome. He was the old philosopher, and he has been hailed as the first natural historian in human history. So Pliny the Elder actually had a group of botanists. They recorded various species of plants according to their color, and actually he hired 4 such artists and botanists, and they used to draw in watercolor. But Pliny actually had a concept: image cannot be used to narrate science. Why? First one is technical. Watercolor doesn't last for too many times, for a longer time. So Pliny thought, well, for our own knowledge, we can use watercolor, but it cannot be used as a conveying media. Second one was deep rooted in old Greek philosophy, because artists can capture only a single moment of science or natural thing or anything, but any natural happenings is happen in sequence, or it's in a flow. So actually you are capturing, if you are an artist, a single ephemeral, not the whole process, not the whole story. It's the old Greek philosophy. So if you notice in our ancient scientific text, there is no image, because the old philosophy is, when you are capturing through image, you are actually recording a single point, but you are missing the whole story. So text is the better way to narrate the whole story. And his philosophy also transmitted to the medieval era, but the medieval era in Europe was a dark period. So there was less communications, and many actually the artistic or scientific cultures were practiced by monks in various monasteries within castles. So people denied or debunked Pliny's philosophy, and they started drawing. So this is a anatomical drawing from Middle Age, and this is botanical drawing, and this is a very famous drawing. It's a wounded man. Actually, a soldier got wounded in a battle. Then the anatomist or the physician performed some surgery, and he actually drew this image. And this is some botanical images. So scientific illustrations in the medieval era was like this. If you notice clearly, these images are not naturalistic, but rather you can say these kind of images are kind of caricature or subtraction of image. So human figure do not like this. This is just a line and filled color. And if you see the botanical drawings, trees are a complex system, but this is subtracted, just the form. If you look at the tree, some kind of form will come in your head, like it's like a snake. It looks like a snake. We used to say this, or it's look like some other form. We actually compare with other forms. The medieval era illustration of scientific recording through drawing was like this. They actually captured the form and view, didn't observe it properly or recorded it naturalistic way. So it was medieval era scientific illustration, but you can get all the scientific information from this, but it was not at all naturalistic. Then the Renaissance happened, the revolution in Italy, and I'll show you. These are Renaissance time art, and actually in Renaissance, historian says it was twin revolution. One is linear perspective and another is printing press. Linear perspective was actually discovered by Leonardo da Vinci, and there's a historian whose name is Samuel Edgerton. His famous thesis is actually all the scientific era on the image and the discoveries, we all are indebted to the discovery of linear perspective. specifically the artist. And another historian, his name is Eisenstein. He said, no, not the linear perspective. Actually, the aha moment of scientific history and the artistic history was discovery of printing press. Why I am telling you? Well, this is a drawing of Leonardo da Vinci. Okay, he actually tried to capture a flower, and this one is drawing by Albrecht Dürer. Dürer was a German artist. So when Italian Renaissance was happening in Rome and Italy, another Renaissance was also happening in the northern part of Europe, in Germany, in the Scandinavian other countries, and France also. So at that time, you can understand, if you can simulate this, the situations, the people were actually started to look at the nature, and they were trying to copy what is naturalistic, what is realistic. But just after the Renaissance, printing press started to come, the woodblock printing. And French philosopher Bruno Latour has mentioned this printing press discovery as immutable mobile. Why? Because just after the Renaissance, people stopped to look at the nature. They were just looking at the printed image. That's why it's immutable, because when it's printed, you believe, well, it's right. When, if any of you are a botany student or geology students, you used to look at the printed image in the book, not go outside, most of the people. And when the first year medical students, second year medical students who are not used to doing the surgery things, they also think the printed image first. It's have to be, it's in our education system. That system started in this way. Just after the Renaissance, people started to look at the printed image, and they just forget to look at the natural image. So in this way, the printed image become immutable mobiles. So this is the anatomical drawing by Leonardo da Vinci, and this is anatomical drawing by Andrea Vesalius, the first anatomist, people used to say. So this is printed image, and this is the drawing from Leonardo's notebook. Historian says, well, Renaissance drawing was really good. Of course, it's good, it's really naturalistic, but it actually didn't play any role to convey the scientific knowledge to the next generation. Why? The first reason was Leonardo's drawing was really complex. Okay, so you can appreciate this drawing, but actually if you are a student of science, you cannot extract many scientific knowledge from this, because it's not subtracted, rather it's real. Like if you are watching photography, it will be hard to extract information from the photography, because there are many informations in there. But if it's graphical, there are selected information, then you can take the information. That's why historian says Renaissance drawing was good, inspiring, but scientifically not compatible. Rather, medieval era drawing were more compatible. This kind of thesis actually was boasted by Michael Mahoney. He is also a scientist and a historian. He said, if you look at the modern day image, it's all graphical, no naturalistic drawing. Even in nowadays, if you say papers like Nature and Cell, their cover images are really fancy, but in discussion, you guys scientists are drawing the discussion image is graphical, just a line to convey the scientific knowledge, not to convey how good you are in drawing or something like this. So in modern science, images are also graphical, geometrized. You are just conveying the real scientific information, but not the image or the power of the image. So actually we are following medieval era image, not the Renaissance type of image. So here I would like to share 2 slides on Galileo's drawing. Well, when the scientific revolution was happening, just the Royal Society was on its way, just 100 years or 150 years before that, Galileo was just playing with his instruments and looked at the moon. At that time, people thought moon was a cluster of some gas. and it is not at all a solid thing. Then the philosopher told to people, no, it's really good. It's actually, it's some godly like thing, and it's this perfect sphere. Galileo was first one who actually discovered, no, it's not a perfect sphere. How he actually used his telescope and drew this using watercolor, brown watercolor. And this is the printed image when it's got printed. If it was, moon was a complete sphere, a perfect sphere, then this kind of image couldn't be generated, this kind of shadow. Why I am showing you this image particularly? Because before Galileo, there was a British scientist who actually drew this. His name was Thomas Harriot. But hardly any people remembers his contribution. Why? Because this is Harriot's drawing, and it has no three-dimensional representation. But Galileo had the knowledge, had the training in linear perspective and geometry. But at that time, Britain was really, Britain was like a rural India kind of thing. Like people, the lots of artisans, people can do many things, but in theoretical science, they were not up to the mark, and even in drawing. So the British contribution, it's got lost from history, and Galileo was the first one who actually drew the moon's drawing. But it was not Galileo, it's Harriot. Why I am in this? This is the role of the image, the geometry, the Renaissance drawing, the Renaissance training, which actually transmitted to the next generation. But the examples are blurred. That's it. So these are the old Florentine perspective problems. Majority used geometry. Actually, Galileo got training from this. So this was the period when the image takes the dichotomy actually started its journey. So people were confused what to use, whether to use image or not. Renaissance drawing was really tough, and there are a handful of people who actually copied nature like them. So it was a turmoil period. And when people were copying the medieval era kind of drawing, there are many historical evidences that people got mocked, and in Britain actually, because Italians thought at that time we are the superior species and we are really good in math, geometry, and art, but other Europeans cannot do this. So there was also a caste system in Europe at that time. So in this, then the Albrecht Dürer started printing press, and the immutable mobile got started its journey. Then people started to say, okay, you do not need to learn drawing, you just convey text, and this is the better way. Even the old Greek philosophers and Roman philosophers said this. So the debate started, and in this way the dichotomy started. But the question is how that dichotomy got established. It's actually the single-handedly was done by a single journal, which is Nature. And this is the year of actually 2019 was the 150th birth anniversary of Nature. And people, the scientists also hailed this as the best scientific journal. The first scientific journal of its kind was the Philosophical Transactions from Royal Society. But in the late 19th century, Nature came into play. And by the Macmillan brothers, they really didn't have any agenda to communicate science. They started a business. They had a club, whose name is Smoke Wine on Friday. They actually want to hobnob with the local scientists, and their agenda was to give advertisement of the scientific consumables available at that time. And even before the Second World War, Nature didn't make any money. It was all loss. So the editors decided, we'll publish image, but like this. Only black and white line drawing. And at that time, even before Nature, in USA, Scientific American started its journey. Now, Nature group is big, and they bought the Scientific American group. So Scientific American magazine now currently publishing under Nature, NPG group. But at that time, it was not like this. Nature was a separate journal in Britain, and within Second World War, it became the biggest scientific journal. But people didn't know that the authority, the Macmillan brothers, were not making money. Then after Second World War, it was a change, it was a shift from physics to biology, and biology itself is a visual kind of science. Even then, they were hesitating to publish good pictures. If you can remember the Watson Crick's, the famous article on DNA structure, double helix structure, there was a single image. And you cannot take any scientific information from that image. Even the paper was really short. If you want to really know how they discovered the DNA thing, you have to buy a separate book, which is Double Helix, written by Watson. So nothing is in the paper. So in this way, in modern era, the separation of image and the text, the battle between image and the text got established. And you can see this image also. Why image is decorative? It's not performative in science. This is the first scanning electron data of synapse by George Gray, and he drew this image. Then in the discussion, this image. Why I am showing you this? Because this image is subtracted. This is not real image of the synapse, subtracted from this data. And Gray was following the medieval era concept of science image interactions, not the Renaissance kind of science image interactions. It's all subtracted. So you can see this evolution actually. This is Bone Man. It was done by some monks in a monastery at Austria, medieval era anatomy. The image text are interacted, it's not separated, but the drawing are subtracted, caricaturized, not naturalistic at all. This is medical drawing by Leonardo from Renaissance period. This drawing is done by Robert Hooke. Robert Hooke, we used to say he was the discoverer of cell, and he used the first microscopist, which is wrong. Galileo was the first microscopist. This is a separate story. During the discussion, I can tell you. But this is drawing by Robert Hooke, published in his famous book Micrographia. And this is this kind of image we now even using in our papers. So this is the evolution of the image. So this is the summary. Just middle age of image subtraction, and the modern science, age of image subtraction. And the Renaissance and the Enlightenment, you see, it's the era of naturalistic drawing, naturalistic image. So it's clear through the different ages of human history, or I will say scientific history or art history, the image text relation is fluctuating. It's not linear, or we cannot create a theory like it's got evolved like this or that. It's fluctuating. So fluctuation is not good to build up a reputation or kind of paradigm. So since it's fluctuating, the interaction, the dichotomy exists, and the people really do not know how to use image or how to use text, how to blend it. And the major role played by the designers of the journals and the economy, of course, because Nature was not getting any money from market, and the journal editors said, okay, let's publish the text and the small image. And at that time, there was no journal except Science to compete with the Nature. And Nature was the most prestigious journal at that time, and most of the good people were tried to publish in this journal. And the Royal Society journal was getting faded away from the market. So it's the multi-layered story. The image tech interaction was fluctuating. People were trying to subtract the image from the real data, from the real photographic image, and the economy played the role. So in this way, the image text got separated like binary opposites. So, and the theory that you do not need image to convey science. It's just decorative. Just subtract the image from the scientific narrative, the theory can stand alone. But just subtract the theory, the text, the image cannot stand alone. Suppose you are, just imagine you are reading a Nature paper written by Watson Crick, and there is a single helical image. nothing is written. You will say, what is this? we do not get it. But if you keep off the image, you can complain, well, it would be good if there was an image, but still we can understand the theory. It's the case. And the responsibility goes to the editors and the designers of the paper, not the nature, the whole history. So I'll tell you more about the fluctuations. It's just brush up what I have said yet. In ancient science, science was a process. So art cannot cover the sequential process because people didn't know that someday in future photography will be discovered. And Middle Age art of subtraction is the era of subtraction, and image immersed in text. The image and text were not separated. And at that time, printing technology was not discovered. The image, text, and the manuscripts were the personal belongings of monasteries. Then Renaissance happened, naturalistic art, too many informations, and image and text got separated again. Because the era of Renaissance was the era when people gave thrust on the image only, not the text. Then modern science, scientific revolution, discovery of printing press and modern science. Again, we are following the subtraction. So these are all the fluctuations. It's not linear. So, and the gap is increasing. So there are these blue colored words are the actually keys of the fluctuations, like sequence, because science is ephemeral thing. It's not something in constant motion. It's in constant motion. And if you are narrating scientific image or scientific happening through your art, it won't be a good idea to draw something naturalistic because of lots of information. So subtraction. And I will address another problem which is currently happening in all the journals. It's very institutionalized kind of their narrative, like in abstract, then you're writing introduction, then the methods and whatever, then the text and with paragraphs, then discussions or conclusions, then reference. So, and each and every journals have similar kind of the format. Here, the main thing is missing, the scientific story. So I can vouch on this concept. If you are reading a scientific paper, you cannot get the science actually from this, because science is actually in the notebooks. People get failure. Nobody mentions, well, while I was doing this, I got failure for 30 times. Why I was failing? For these reasons. But when the Royal Society started its journey, if you go back and read their papers from 1665 or 17 up to 1869 or in 1900, when the nature started its journey. Before that, Royal Society's journals, the narrative was like a story, like scientists were writing a diary. So this was the real narrative, I think. But the problem was they have a format to publish the image in folio format, like text, then a fold of a big image. Again, text. So text and image was separated again, even not immersed within the text or within the body of the text. So separation existed, and when the nature started its journey, the separation established. So the missing point in scientific narrative through art is sequence, second is subtraction, and third one is the story. Well, so I believe there is a way out, and people explored this. Sequence. So this is Harold Edgerton from MIT, who was the official photographer of Trinity test. So this is how the US Marines were actually testing the first atom bomb in the desert. So Edgerton actually captured the image, and he was the discoverer of flash photography. So Edgerton was actually carrying the legacy of Arthur Worthington. Arthur actually was the first one who imaged drop of a water on a water surface. This is very famous experiment. And in spite of publishing the image itself, he drew the sequence like subtraction, following the medieval era philosophy. And it is more clear because if you look at the photographs, it's really hazy and lots of information is there, but the basic pattern is same. Basic pattern is this actually, when a water drop falls on a water surface, this is the happening. But in this photography or this attempt to narrate science was lacking the story, the image text informations, which I think there is art from which is comics. I am a comics artist, so in comics really the image and text are immersed actually. So, but before going to comics, I'll share you some maps with you, because in history of science, a single paradigm or single genre, whatever you say, really tried to mix the image and text. Who are the atlas makers or the cartographer or map makers? There is a famous book, you should read this book, is Objectivity by Peter Galison and Lauren Baston. They addressed the old atlas maker actually narrated science, any kind of science, in the most perfect way in history. But the other scientific discipline like physics, chemistry, biology, and other big sciences, they didn't learn anything from them. We just say map makers or atlas makers are from a single discipline like geography, but their storytelling is far superior than any scientific narrative. Well, this is a 15th century map, Atlas of Sea Monsters, full of stories. At that time, the coordinate was not developed, but just this, well, the picture is really blurred, but all the places and what is happening with image, with information. And this is the famous map of Chimborazo. It was drawn by Alexander von Humboldt. So 2019 was the 250th birth anniversary of Alexander von Humboldt, the most famous German naturalist, whatever you say, or scientist. At that time, when he climbed Chimborazo, Mount Everest was not the highest peak of world, because people didn't know that. At that time, Chimborazo was the highest peak, and Humboldt explored the height and all the species and the ecological up downs, everything, and put down all in a single interactive map. So this was the real and the most innovative way to represent science. All scientific data is there, and the story and the image also. But other discipline of science didn't explore this. And this is Charles Minard's map. He has been hailed as the father of infographics. Even other discipline, scientific discipline, didn't learn anything from this kind of representations. We just call them cartographers. But they are real scientists. They were, at that time, even in the 19th century, they were really playing with big data and representing through images. And the story of map making. This guy is Jim Eno, the director of Counter Mapping Project. The map we see actually today, the Google map or other kind of map, is the European or the white skin version of map. Before that, native people actually drew map. It's all using all stories. And this is called Native American Juni map. Juni map is all about stories, no coordinate, no mathematical data or data points, anything, just stories from memories. If I ask any of you, well, I have got lost in this campus and I want to go to this canteen or to Leslie's office, so you'll tell me, just use your map? No, you'll tell, well, go there, you'll find this, then go there, use the stairs. So it's a sequence of stories. Native people actually use this kind of stories. Go there will be a tree. It will be the start of Colorado River. Then go further in this way. So Jim Enote was a museum director and a Juni farmer. And one day he was actually showing some Google map what on his farming land to her mother. And her mother told him, well, Jim, I am not a bird. Bird can see like this. I am a human. Okay, so how human can perceive map in this way, stories. So why I am showing you this? So map can be created using stories also, not just using coordinates. So all of this knowledge can be gathered in a single art form, I think, which is comics. So comics is a new form of knowledge, and this is the rhizomatic relationship between image and text. It's the quotation by Nick Susanis. Nick Susanis actually did his PhD from Columbia University, and his PhD thesis is Unflattening, is the first thesis written in comics, and the first book in the history of Harvard University Press, which is published in a comic format. So Harvard University Press never published any comics before that, before Nick. And this is the page from his PhD thesis. So, well, now this is a page of a comics. You will find all the answers of the problem through the course of human history of science and art. This is subtracted image. So this is drawn by Joe Sacco. Joe Sacco is a journalist, graphic journalist, and he went to Bosnia to cover the Bosnia war, through which Yugoslavia broke apart. So this was the first day when the war broke out, and this is subtracted image. Lots of information, but subtracted. Just consider if this was a image of or photographs, there will be lots of noise because noisy thing was happening at that time. But this is subtracted, and there is a story, and this is also his image from Gaza Strip. He is a Middle East lover and used to go there to record their lives. And all these images are subtracted, not naturalistic drawing, just the required information. But in science, how we'll use comics in science? So in late 50s and 60s, science comics actually started its journey. But I have read lots of science comics, perhaps all of the famous one. But this one, I think, is the best thing has published ever. It's 40 Jumps by Kees Boix. Kees Boix was a scientist and philosopher from Europe. And these images are history of universe, from atom to a solar system. And I am showing you the inside of his book. Is the name of the book is Views of Cosmos. This is the inside page of this book. So a single image, unit of the whole story, and he later explained each of the image so that people can get it. So this is I think, the first really technically the science comics. And this is a page from the graphic novel Trinity. Why I'm showing this? So what is happening inside the atom bomb when they were testing, actually? So it's the artist actually taken reference from Edgerton's image, which I have already shown you. But what was happening inside the bomb? So this is the thing, the chain reactions. So comics artist can do this, just reading the all physical scientific theory, and he imagined what was actually happening. And this is my favorite science comics, this one actually. This is done by Larry Gonick. Larry Gonick is the most famous science cartoonist in this world. He was a mathematician from MIT. He has an India connection because he did his summer training in Tata Institute of Fundamental Research in 1967. Then he went back to the Harvard and MIT and dropped, like me. So then Larry Gonick started his journey in cartoon, and both of the comics are depicting same story, how life got started in Earth. This is drawing by Gonick and published in Discover magazine in 90s. And this is drawing by Susanis. It was published in Boston Globe in a couple of years back. Both are depicting Beautiful theory by Jeremy England. Actually, when Gonick drew this, Jeremy England was a kid, but he somehow predicted the theory. And Susanis actually drew his theory. So Jeremy England is a physicist from MIT and a biologist. Just search his name in internet. In 2015, he published a paper in PNS, and now Jeremy has been hailing as the new Darwin, because actually he solved what is life. Actually, at least he is claiming. So how life got started in Earth. So this is the comics. Just I am not explaining the comics, so because we have lack of time. But this is the comics how the life could get started and the energy diagrams, because in equilibrium system it's clear that from ice, when it gets melt, water can form, but naturally water cannot get back to the ice. So in this way, when the earth was in chaos, the temperature was high, how some tiny molecules like RNA and other molecules, they got assembled and created a clump. It is really a mystery. So Jeremy's energy dissipation theory says, well, it's not mystery. So just read the paper, since you guys, many of you are scientists, and read his comics. It's available in the internet. So this, so far I have shown you the comics depicting science, but now people are creating data comics. What is data comics? So people are actually using big data, scientific data, actual data published in papers, and they are creating this kind of narrative, the scientific narrative, just far away from the usual scientific narrative published in journals. So this is the great place cell experiment, Joan of Kiffy's. So it got Nobel Prize in 2040, which is 2 students from Norway. And this comics is drawn by Matteo Farnella from Columbia University. Actually, in 2018, Matteo Farnella and his friends, Benjamin Buck from Edinburgh University, they arranged the first data comics conference in Columbia. So this is their output. So the concept is what you are doing in lab, you can create this kind of beautiful scientific narrative using the real data. So this is a new form of knowledge, what I was talking about. And Nature also published the data comics. So it's again driven by Nick Susanis in 2015. At that time, he hasn't published the Unflattening, but it was actually his first breakthrough. So Nature published this comics, and the same year, it was 2015. So 100-year celebration of Albert Einstein's general theory of relativity. So in the same month, Science also published a science comics on Albert Einstein theory. So it was a rivalry of two big business house, Nature and Science. But good thing is they both published their first comics in 2015. So academia and the journals are also accepting comics. Now I will show you a little bit of my work, what I am doing. So my chosen area of work is history and philosophy of science. It is really a little bit complex than the usual science. It's again the same historical divisions, and at that time the belief was the dominating factors. Michel Foucault's episteme, the word is, then the observation, people started to look at the nature and started to think, then the birth of scientific theories, because up to the Renaissance there was no theories, just observation and interpretation. Then people started to do the experiment, and they started to hypothesize nature. They started to simulate nature and its behavior in their brain. So in this way, the scientific theories got born. And then the era of experiments, now we are in the era of modern science. We love to do lots of experiments, and then these kind of thinking were dominated by the global connectivity through Silk Route, discovery of the steam engine, the penny post, how actually they got connected to each other at that time, because at that time there was no internet and Facebook, nothing. So then the material culture won, because to do modern science you need good materials, the machines and the elements. So parallelly all these things uh, was actually all these things created the whole history of science, and this is my area of interest, but to narrate through comics. But in science, the scientific illustrations from observations and then reconstructed image, then science comics and data comics now. But history of science, what is the mode? What is the so people really has done this before. This is the drawing by Joseph Wright, but this is a single image. Again, just like the scientific single illustrations. So again, the way out is comics. This is also single image. Actually, uh, this was the most important moment last year in science. So discovery of the image, not discovery, the recreation of the image of the black hole. So on that night, I was just sitting in my room and I thought, well, since I know the whole history of black hole, I read this before out of my personal interest. So let's do a comics on this, because what people are saying is a single image of the black hole and the woman behind this, Katie Bowman. There was a lots of people, but she got the most attention. So I created this comics on that night, and I'm lucky enough because at that time New York Times was also planning to create a comics and the Guardian, but I tweeted this before. So New York Times retweeted. Well, say this cool stuff. This Mr. Manna from India has done this before us. So it's just like a small recognition. So what I am trying to say is the image the Katie Bowman actually reconstructed is carrying all the historical data and all the scientific thoughts, not only the multiple event horizon telescope data. She actually used many scientific data started from GPR Luminates experiments and the drawing. This is the drawing by GPR Luminates, and I recreated this. Luminate actually was the first one. He drew the image of black hole, and it's really uncanny that it's quite similar to the real image. And this is all the histories. In this way, actually, the image of the black hole got reconstructed. And you can see this image was used by Christopher Nolan in his famous movie. So when Nolan actually released his movie, just before the year, Keith Thorne visited to Calcutta, and I met him in Indian Museum. Actually, Keith Thorne was a physicist from Caltech and Nobel laureate, you know this. And Thorne said to me, "Don't tell this to anyone. Actually, Nolan paid me a huge amount, but I have told him how to draw the image." And then Thorne mailed me, "Well, I am not happy with the image because Nolan actually distorted the image of the black hole, but it's beautiful." So yeah, this interview was published in Telegraph. And so these are my history of science kind of comics. So I think reading this kind of scientific narrative, people can know the science and the historical background also. It's published in a club side. It's a small online journal, but they're my friends, so I contribute lots of free stuff to them. And so over the years, actually, I am developing a history of Royal Society and Robert Hooke. My collaborator is Dr. Ian Lawson from Max Planck Institute of History of Science. So far we have created 120 pages graphic history of Royal Society and Robert Hooke, how the modern science started its journey. So we have a plan to finish this book end of 2020, so we can create 200 or 250 pages book, the history of science, modern science and the Royal Society in comics format. So this is on the page of this book. Everything is there. Like it's young Robert Hooke, and actually before the Royal Society there was a club Physical Mathematical Club of Wadham College, Oxford. So here there was an anatomist whose name is Thomas Willis. Thomas Willis was more capable than Andre Vesalius even, and published his anatomy book, Cerebri Anatomy, the first anatomy book published in Britain. And it's, if you can see the image, so you can understand he was far superior than even Andre Vesalius. And if you have some medical knowledge, like if you read physiology, you must have heard about the Willis circle. It's in our brain. So Willis circle was discovered by Thomas Willis. And Robert Hooke and the Christopher Wren was apprentice in his laboratory in 17th century. And it was the germination stage of Royal Society. So I am trying to capture all the science and the history and its evolution through comics. So my work. It's another story of the first scientific society in India. So I have created this comics, and it was published by Danish National Archive also in their paper. Just few images, not the whole comics. So this is the journal written by Nicholas Jensen. Is from Danish National Archive. So anyway, so I'll end with minutes. So it's textual knowledge, theory, art, and the data, all we can intermingle in comics. So in this way, you can create a new form of knowledge, just experimenting with the current scientific narratives. I'm not saying you have to do something new or thing, just we can think in an innovative way, because I believe scientists, not only scientists, people who are working in any discipline, they think in visuals, have to be. But when they are putting their thinking on paper, they used to use text, because this is called actually language or linguistic determinism, because we are so driven by our language. But visuals, image can be a separate language, and we can mix this in a rhizomatic way, what Nick Susani says. So, before closing my talk, I'll tell you what I have showed you or delivered you. Luigi Galvani, the father of electrophysiology, knew all of this in 18th century. Just see his scientific illustrations. He was drawing comics in his paper in 18th century. This is beautiful comics, and these illustrations are unpublished. Actually, when he published, he slightly changed the mode of his illustration. So it got lost in the comical or the graphic narrative's essence. But these are his first drawing, and it's unpublished. Another one, it's in sequence, in subtracted, and all the scientific information is there. And there, just if you closely look at the picture, you will get all the scientific information. Hardly any text is needed. So please follow my blog. This is my blog. And thanks to Leslie and the whole IITGM community and my collaborators. And actually, comics is a thing nobody wants to fund. So this group, STEM Peers, it started as a Facebook group. Then now they are giving fellowship or funding to people who are trying to do something new. They gave me fund and financial and moral support. Thanks. That's it.
Okay.